Hello, hi everyone. Welcome to this tour in the brand. This is your Shiva sir. So today I'm going to explain about light reflection and diffraction. Light reflection and diffraction chapter. Light reflection. Light reflection and diffraction chapter. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Okay, so I'm taking the plane mirror. This is a plane mirror. This is a plane mirror. Okay, so here I'm considering silver coating, another side is reflecting surface. One side is reflecting surface, another side is silver coating. When incident light ray is falling on it, incident ray, this is the incident ray and reflected ray, incident ray, reflected ray, incident ray and reflected ray. Incident ray, reflected ray. So the line which is perpendicular to the plane surface is called normal line. The line which is perpendicular to the plane surface is called normal line. Here you can observe the light ray which is undeviated or extension of incident ray, that is called undeviated line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And the angle between reflected ray and undeviated line is called angle of deviation. This is the angle of deviation. Okay. So here you can observe incident ray, reflected ray, normal line lies on the same plane. Incident ray, first point. Incident ray, reflected ray, normal line. Okay, laws of reflection. These are laws of reflection. Laws of reflection. Incident ray, reflected ray, normal line lies on the same plane. And coming to the next one, angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay. Then the linear angle is 180 degrees. If you observe the linear angle is 180 degrees. So this is the linear angle, 180 degrees. On the same line, so you can observe, on the same line you can observe angle of incidence, angle of reflection plus angle of deviation, because this is the linear angle of incidence plus angle of reflection plus angle of deviation, right? Now, so you can take angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Clear? Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay, done. Clear. So now here from this laws of reflection, angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So by that, angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. So at the same time, so we can also write angle of deviation 180 minus 2 angle of reflection. to angle of reflection. So angle of deviation equal to 180 minus 2 angle of incidence, and angle of deviation equal to 180 minus 2 angle of reflection. Sir, how did you take like that? Okay, so here you wrote angle of incidence. In the second step, you have written angle of reflection. How it is possible? Generally, so we discussed from laws of reflection, an incident ray reflected a normal line. Incident ray reflected a normal line lies on the same plane, and angle of incident is equal to angle of reflection. From that, so instead of angle of reflection, if I write angle of incidence, so I can write angle of deviation equal to 180 minus 2 angle of incidence. So at the same time, instead of angle of incidence, if I write angle of reflection, so I'll get angle of deviation equal to 180 minus 2 angle of reflection. So like that we can write. Like that we can write. I hope it is very clear to you all, right? Yes. So next one, this is about reflection. Reflection phenomenon is nothing but the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface, or of the phenomenon of reflecting of light from the reflecting surface. Here reflecting surface is plane mirror. So one side is smooth surface, another side is silver coated. Incident ray reflected a normal line, and we can take like this: incident ray reflected a normal line is on the same plane, and angle of incident is equal to angle of reflection. From that we can write so like that: angle of deviation equal to 180 minus 2 angle of incidence, angle of deviation equal to 180 minus 2 angle of reflection. Okay. So next one, so we'll discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection. So what is regular reflection? Regular reflection is nothing but, so I am taking the plane mirror. So this is the plane mirror. This is the plane mirror. So incident ray, this is incident ray, and a reflected ray, and I am taking the normal line. So this is a reflection phenomena, right? But what about regular reflection and irregular reflection? Same. So here you can see, so these are the incident rays. These are the incident rays. Then if you observe the reflected light rays, so this is the incident beam. Incident beam is parallel. This is a reflected beam. Incident beam and reflected beam. So incident beam is parallel to each other. So at the same time, after reflection, reflected light rays are also parallel to each other. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Regular reflection. Regular reflection. Incident beam is parallel, then reflected light rays are also parallel to each other. Then this type of reflection is called regular reflection. Coming to irregular reflection, irregular reflection. So here you can observe. So incident light rays are parallel, but reflected light rays are not parallel to each other. Incident light rays are parallel. These are the incident light rays. Incident light rays are parallel, but reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. So here you can observe. These light rays will move in different directions. So here incident light rays are parallel. Okay. Here incident light rays are parallel. Incident light ray. Incident beam we can say. Incident beam. But here reflector light rays. Reflector light rays. Reflected. Reflector light rays are not parallel to each other. Okay. So they are moving in different right. Reflector light rays. So they'll move in different directions. So this type of reflection is called irregular reflection. Irregular reflection. Regular reflection takes place on smooth surface, still water. Regular reflection takes place on smooth surface, still water, and plane mirror we can take. What about irregular reflection? Irregular reflection takes place on rough surface, like a wall. Like this example we can take. Okay. Now Now object and image. So now I will discuss about object and image. So let's discuss. I have taken the plane mirror like this. This is a plane mirror. So this is the object. Plane mirror object. Okay. So plane mirror. So plane mirror I am taking. So here from this one, these light rays are coming. Okay. After reflection, the light rays are moving away from it. After reflection, those light rays are moving away from it. If you are extending those light rays, extended light rays are meeting at one point. Okay, so here you can see. So virtual image, real object and virtual image, real object and virtual image. Okay. So object in this case, object is real, object is real, object is real, image is virtual, image is virtual, image is virtual. So coming to the second case, so I am taking this case, this is the case. Okay, so light rays are coming from object, so I am taking here like this and like here also. So after reflection, those light rays are meeting at one point. You can observe here. So here real image, and if you are extending these light rays, so their virtual object will be there, virtual object. Okay, so I hope you will get to know the definitions of real image and virtual object. So here observe carefully. So real image and virtual object. So object is real, object is virtual in this case. Object is virtual and image is real. Image is real. Okay. So observe carefully in this case. Object is real, real object and virtual image. Object is virtual, image is real. Image is real. So that coming to the definitions of the definitions. First point is real object real object, and the second one is virtual image, and coming to third one, real image, and the fourth one is virtual object. Coming to the definitions of real object. The point of intersection of incident light rays. Here incident light rays are coming from the point. The point of intersection of incident light rays is known as real object. Virtual image. Coming to virtual, the point of intersection of extended reflector light rays. So we are extending the reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Coming to real image, the point of intersection of reflector light rays. Here these reflector light rays are meeting at one point. The point of intersection of reflector light rays is called So here the point of intersection of reflector light rays is called real image. Point of intersection of extended the point of intersection of extended incident light rays. Extended incident light rays is called virtual object. Okay. So if you observe these two diagrams, we can conclude that one thing. If you observe these two diagrams, we can conclude one thing. Object is real, image is virtual. Object is virtual, image is real. Object is virtual, image is real. Okay, na? So like this, vice versa. Object is real, image is virtual. Object is virtual, image is real. I hope it is very clear. Just check once, check the diagrams. Okay, so check once. Okay, so next you can see now nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror will discuss. So nature, if you are taking this a plane mirror, okay. So I'm considering like here, this is the real object. A, B, okay. So A, B I'm taking. So from this, I'm considering 2 points. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays, right? Yes. So here you can observe. And here also I am taking like here. How many light rays? Minimum 2 light rays are required to form the image of the object. So A dash, so here A dash, and this one is B dash. A dash and B dash. Okay. So first point is point number 1. Object is real. Object is real. Image is virtual. Object is virtual. Image is real. Point number 1 is object is real. Object is real. Image is virtual. Image is virtual. Object is image is real. Object is virtual. Second point. So the distance between, this is the object distance, the distance between object to mirror. So the distance between object to mirror is called object distance, and the distance between mirror to image called image distance. The distance between object to mirror is called object distance, and the distance between mirror to image is called image distance. So object distance is equal to image distance. And coming to third one, height of the object is equal to height of the image. Height of the object or size of the object is equal to size of the image. And coming to the fourth one, magnification, that is nothing but V by U. Magnification is +1. And also it shows lateral inversion. Lateral inversion. Lateral inversion. So once again, point number 1, object is real. Object is real. Object is real. Image is virtual. Object is virtual. Image is real. Object distance is equal to image distance. Height of the object is equal to height of the image, and also it shows lateral inversion. What is lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image, or left side of the object appears to be right side of the image. So mirror image. So just if you are standing in front of the mirror and looking at you in the mirror, then what happens? Our right side object appears to be left side, or left side object appears to be right side. Okay, so this mirror image is called lateral inversion. And you can observe the ambulance word written on the vehicle, it will be in the mirror image. So if you see in the radio mirrors, in the cars, bikes, we can able to see that word clearly. Okay, so that is example for lateral inversion. I hope it is very clear to you all, right? Yes. Next one. So next a few questions we'll discuss related to plane mirror. Till now what have we discussed? These are the questions. I'll write on the board. Just try to answer the questions. First point number 1. So these are the questions. So check once now. And marks for these questions. How many marks? For how many marks they will give in exam? That also I'll write. So this is for 1 mark. And this is for 1 mark. And define regular reflection, irregular reflection, 2 marks. And list the characteristics of the image formed by the plane mirror is 2 marks. And lateral inversion, so maybe 1 mark they make you for 1 mark. So this is, they'll ask for 1 mark. So define reflection of light. Define reflection of light. So here you can observe, reflection is nothing but the bouncing back of the light from the reflecting surface is called reflection of light. Bouncing back or reflecting back of the light from the reflecting surface is called reflection of light. Okay, so that is for reflection. 2 types also they'll ask. So here I will get regular, irregular. So state laws of reflection. Laws of reflection. What are the laws of reflection? So incident ray, reflected ray, normal lies on the same plane. Angle of incident is equal to angle of reflection. And coming to define regular and irregular reflection. Regular reflection, incident beam is parallel and then reflector light rays are also parallel, reflected beam also parallel. Okay, so then this type of reflection is called regular reflection. Coming to irregular reflection, incident beam is parallel but reflector light rays are not parallel to each other. Then the type of reflection is called irregular reflection. Coming to list the characteristics of the image formed by plane mirror. Characteristics. So what are those? So here in the previous example we discussed, okay, object is real, image is virtual, object is virtual, image is real, object distance equal to image distance, height of the object is equal to height of the image. Okay, and also it shows lateral inversion. Those are the characteristics of the image formed by the plane mirror. Coming to the lateral, what is lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. This phenomenon is called lateral inversion. I hope it is very clear. So regular reflection, loss of reflection, define reflection of light and loss of reflection, regular and irregular. So list the characteristics of the image formed by the plane mirror and what is the lateral inversion. So these are the questions. Next, so a few more questions are there. So we'll discuss. So what type of image is formed? So try to answer it. Let me the answer. So at 11:10 I will give the answers. 11:10, or I can take 11:05. 11:05 I'll give the answer because very simple only, no? At least I'll give an option to you to answer. 11:05. I'll answer it. Okay, so the answer is, you can check the answer for on plane mirror virtual image will form, on cinema screen real image. On plane mirror virtual image, virtual image, on plane mirror virtual image, on cinema screen real image. Okay, next, so we'll discuss one more question. So differentiate between real image and virtual image. Question is, differentiate between real image and virtual image. So can you do it? Real image and virtual image. This is a real image and a virtual image. Differences. Anyone? I'll give 2 minutes. 2 minutes time. So try to answer it. If you know, just let me know. Okay. So here you can observe real image. First point. So normally real image, if you are taking camera like this, after reflection, light rays will meet at one point. The point of intersection of actual light rays meet. After reflection, light rays directly meet, then image will form. That type of image is called real image. So reflector light rays, directly reflector light rays will meet at one point on the principal axis. Reflector light rays. Reflector light rays will meet at one point on the principal axis, then we can say real image. Here, if you are taking the convex mirror, so these are the incident light rays. After that, if you are extending these light rays, the image will form here. Extended reflector light rays are the point of intersection of extended reflector light rays. It appears to meet at one point. So that is called virtual image. And coming to the real image can be obtained on the screen. Can be obtained on the screen. Obtained on the screen. Okay, so here virtual image cannot be obtained on the screen. Real image, virtual image cannot obtained on the screen. Obtained on the screen. Or cannot caught on the screen. Obtained on the screen. And coming to third one, here real image always inverted. inverted. Coming to virtual image, always erect. Real image always inverted, virtual image always erect. Okay. And coming to the fourth one, okay. So what is fourth one? Fourth one is, anyone? So real image formed by concave mirror, convex lens, real image, concave mirror and convex lens. Coming to the virtual image, convex mirror, and concave lens. Understood or not? So once again check here. So real image formed by concave mirror and convex lens, whereas virtual image formed by convex mirror and concave lens. Right? Yes. So this is about difference between real image and virtual image. Difference between real image and virtual image. Okay. So next, one more question we'll discuss. That is, all right, just try to answer it. So can you answer to these questions? If you know, just try to answer to these questions. Answer is radius of curvature of plane mirror is infinity. Infinity. And what is the power of plane mirror? So normally radius of curvature r equal to 2f, f equal to r by 2. Okay. Then automatically power equal to 1 by f. So r equal to infinity, f also infinity for plane mirror. Then 1 by infinity, 1 by 1 by 0, then 1 by 1 into 0, then you will get 0. Power of plane mirror is 0. Okay. So what is speed of light now? Free space. 3 into 10 power 8 meter per second. Okay. So 3 into 10 power 8 meter per second. I hope it is very clear. Next question. Which type of reflection of light? Reflection of light. Which type of reflection of light? Reflection of light. Reflection of light leads to the formation of images. Formation of images. And next question is, what is the difference between? Question is, what is the difference between regular reflection, so these are the two questions. Try to answer it. So which type of reflection of light leads to the formation of images? Regular reflection. Regular reflection leads to the formation of images. Regular reflection. Regular reflection. And coming to the what is the difference between regular reflection of light and diffusive reflection of light? So in regular reflection of light, regular reflection of light, regular reflection of light, regular reflection of light in this, so incident beam is parallel, then reflector light rays are also parallel to each other. Okay, so you can observe regular reflection. Incident light rays are parallel, then reflector light rays are also parallel to each other. Coming to irregular reflection, incident light rays are parallel but reflector light rays are not parallel to each other. Regular reflection of light. Coming to irregular reflection, irregular reflection. Irregular reflection. Irregular reflection means, so surface is not smooth, surface is irregular. So here you can observe. So incident light rays are parallel but reflector light rays are not parallel to each other. So like this, light rays will move in different directions. So there is a difference. Which type of reflection of light leads to the formation of images? Regular reflection. And what is the difference between regular reflection and irregular reflection? Means regular reflection, incident and reflector light rays both are parallel to each other. So whereas irregular reflection, incident light rays are parallel but reflector light rays are not parallel to each other. So this is very very important. So try to answer this question. Can you answer to this question? If anyone knows the answer, just you can comment in the comment section. So 5 minutes time. Okay, now it's time for answering the questions. Cinema screen. On cinema screen, irregular reflection, irregular reflection, irregular reflection, and a plane mirror regular reflection, and coming to the cardboard also irregular reflection, and coming to the still water regular reflection, and still water it is regular reflection, regular reflection. Okay, so once again observe. On cinema screen, irregular reflection, plane mirror regular reflection, cardboard irregular reflection, and still lake water is regular reflection. Okay. Next. So here the question is, a wall reflects light and a mirror also reflects light. What difference is there in the way they reflect light? What difference in the way they reflect light, right? So here you can observe wall, a wall and a mirror. Wall, you can see irregular reflection takes place. Wall on wall, irregular reflection, irregular reflection. So first one, coming to the two, on mirror regular reflection, on mirror regular reflection, regular. Okay. So on wall, irregular reflection takes place, on mirror regular reflection takes place. So that is the difference in the reflection of light in these two cases. So regular means incident beam is parallel, reflector light rays are also parallel. But wall, if you say incident beam is parallel but reflector light rays are not parallel to each other. Clear? Yes. Next question. Under what condition question is so incident ray and reflected ray will always will always will always always be parallel to each other. So whatever may be angle of incidence, angle of So see here, under what conditions in an arrangement of two plane mirrors, incident and reflected ray will always be parallel to each other, whatever may be the angle of incidence. So the same with the help of diagram. Okay, so now you can see here. So two plane mirrors must be perpendicular to each other in order to get the incident ray, reflected ray. Incident ray. So again it will be reflected here. Then it will be reflected like this. So this is a normal. This one is a normal to the surface. Angle of incidence, angle of reflection. So theta 1, theta 1, theta 2, theta 2. Okay. So in this case only, incident ray and emergent ray and reflected ray will be parallel to each other. Okay. So I hope it is very clear now. Next question is, what are the uses of plane mirror? What are the uses of plane mirror? So you can discuss this question later. So answer in the comment section if you know the answer. Thank you.